Hello student, and name of the chapter is shear force and bending moment. In short, even we can say that SF and BM. And SF, where SF stand for shear force and BM stand for the bending moment. Now, what is the term means SF and BM? Now let's see. Now here we can see that it is a simple supported beam, two ends supported RA and RB, and length of the beam is L, and W load acting over it at the middle of the span means length of the beam L's and W load acting over it in L by 2 distance. Now in the shearing force, due to the load W, the load W is try to the share the beams, mean load W try to the beam into split into the beam into two parts, that means sharing the beams. This force is called the shearing force or shear force. Instead of sharing, the beam may be bending this like, and here one is two things. One is beam is shearing into the two half, and another is the bending of the beams. Now in this chapter, shear force and bending moment is basically the graphical solutions, and it is deal with the basically the graphical solutions, and it will represent in graphical diagram. It will show it will can easily show you the which point of the beam is sheared and which point of the beam is bending. In this diagram we can easily show you the where point beam is bent or where point beam is the shearing. Now definition of shear force. What is shear force? The shear force is the algebraic sum of the force acting either left hand side or right hand side of the section of the beams. Means here it is a simple supported beams and W load acting over it in the middle of the spans, and length of the span is L. If shearing force, if I take a one section from here, then shear force is the summation of algebraic summation of either left or right hand side of the section of the beams. Means if W is the if I take a section from here and W1, W2 and W2 the left hand side of the section of the beams, then shear force is W1 plus W2 plus W3 in the left hand side. If another load and W4, W5 and W6 the another sides, then also shear force we can summation all the forces right hand sides like W2 plus W3 plus W6 in these manners. This called the is the algebraic summations of the either sections, either left or right hand side of the section of the beams. So it is a shear force, so its unit may be newtons or kilonewtons. Now bending moment. Now definition of bending moment, it is defined similar at that the shear force, and it is defined as the algebraic sum of the moment of the force acting left or right hand side of the section of the beams. Means if you take a section here, and the moment of the sections from left hand side or moment of the section from the right hand side about a fixed point. Suppose if you take a moment from point A, then these summations take a moment from fixed point A, then moment equal to this moment is a one kind of clockwise movements. And if I take a moment from B, and this is from point B, and it is a anti-clockwise movements. So anti-clockwise movements, then it is the all algebraic sums of the moment either left hand side or right hand side section of the beams. section of the beams. Then what is the unit of the bending moments? The unit of bending moment is Newton into meter or kilonewton into meters. Now sign conventions. In sign conventions, very important things while drawing SFD and BMD diagram. Now take a section here. If the force uh, left hand side of the section of the beams is upwards, and in right hand side is the force is downward, and both the forces we can take in positive, we can take the positive. And again we can take another sections if left hand section of the force is downwards and right hand section is upward, and we can take the negative. So this manner we can take the sign convention for shear force. Now here sign convention of bending moment. Take a section from here. If the moment, if a section, if the left hand side take a moment from the clockwise and right hand section of the moment take a anti-clockwise, and this type of moment is called the positive. And if take a section from here, if left hand section movement is anti-clockwise and right hand section from the anti-clockwise, then this is called the negative movements. In positive movements, bending moment is called the sagging, and negative bending moment is called the hugging of bending moments. Now while drawing SFD and BMD, the shear force diagram and bending moment diagram for graphical solutions, where the bending moment is occurred and where the shearing is occurs, the basic importance some point may be noted while drawing the SFD and the BMD diagrams. Let's see. First point, length of the SFD and BMD must be equal to the span of the beam. Means if length of the beam is suppose L, so that SFD and BMD, that means shear force diagram and the bending moment diagram also be length maybe L units. SFD is, next point, SFD is drawn below the loaded beams and BMD is drawn below the SFD. Means while drawing the first of all we'll draw the loaded of the beams, then after that draw the SFD means shear force diagrams, after that and below the BMD means bending moment diagram. Means first loaded beam, then SFD, after that BMD must be drawn as same manner, and length of the beam is the same for both the diagrams SFD and BMD in the previous point already discussed. Next, for simple supported beam, the beam is 0 at the supports. When finding out the bending moment at the fixed point, if you find out the moment at a fixed point, means the point, suppose fixed point is the load W and load by reactions RA or RB, whatever may be. When load into distance is equal to moments, means when we find out the moment at a point about a fixed point, the length equal to 0, then means if reactions or load is acting over it but length is 0, then means load into length is equal to 0. That's why simple supported beam, the BM is 0 at the fixed support. In a cantilever beam, the beam also be 0 at the free end in the same manners. Next point, the calculating the SF and BM of all critical point. All critical point must be calculated the SF and BM diagrams for loaded beams. If the no load is present between the 2 points, no load is present, then the SF be constant. SF diagram, if no load present, in the absence of any load between the 2 points, the BM diagram is constant. Then so if no load present between the 2 points, then SF will be constant. And next lectures we will see you the how the SFD and BMD diagram is drawn, and next class we will solve the simple problem of SFD and BMD. Thank you.